regular once we're talking about radian, and if your calculator says radian, anything that you do that has something to do with the angle, let's say cos of something. Okay, I'll go like this. Cos, if I go cos of pi, it's going to give me -1. Right? If I go cos of 90, because I'm thinking 90 degrees, or 180, I'll go 180. So the calculator still thinks it's not 180 degrees, it thinks it's 180 radians. So it's going to give us -0.59. We know cos of 180 in degree is -1. So, but yeah, so make sure your mode is in degree if it's asking for degree mode, and radian if it's asking for radian mode. Okay, so good afternoon everybody, and like I said, this is going to be a really long lesson, but we're going to try to finish this to accommodate people who have appointments. So we talked about radian measure yesterday. So today what we're going to do is we're going to talk about coterminal of angles in radian measure. Now let's kind of revisit what coterminal is. It means co is mean the same thing, and then terminal where it stops, right? So where it stops in the same place. Now where did we talk about coterminal? Let's go back. Let's go back to when we first talked about coterminal. When we talked about coterminal angles, that was in lesson 1, right? Coterminal is, let's go back here. Coterminal angles would be theta plus 360 degrees times k. K tells us how many full rotations that we need to do. So in this particular case, how can we change our coterminal? In radian mode, in radian measure, and it's going to be theta, and that's going to be in radian mode, right? Theta in radian. What's a full rotation? 360, but in radian is 2 pi. So 2 pi, and then times k, where k is an element of an integer. Okay, so let's put that down. So once we know 1, we can figure out other coterminals for that. So when we have, for each of the angle and sine position, determine the measures of one positive and one negative coterminal. Okay, so let's see, where is, can you imagine where pi over 4 is located? So this is 0, this is pi, this is pi halves, pi over 4 would be here, right? So pi is there from 0 to pi, but we want to cut it into 4 equal parts to get the 4. So pi over 4 is there. So theta is equals to pi over 4. Now we want to do one positive, so that means we can go all the way around once and another pi over 4 to get a coterminal. Okay, is everybody okay with that? So we can go around once and a bit, and that's where we're gonna stop. It stops in the same place, right? So if we do that, it's gonna be pi over 4 theta, start with the formula, theta plus 2 pi times k, and then here the k we're gonna rotate once. So pi over 4 plus 2 times pi times, we're going to rotate once, it's pi over 4 plus 2 pi when we're doing this, we need to have the same denominator, so we're going to multiply by 4/4. Okay? We know this from a long time ago. So that's going to be 8 plus 1, so it's 9 pi over 4. So if we go 4 pi over 4, and if we go 9 pi over 4, we're going to stop in the same position. Okay? So that's that. Now, that's a positive. What about the negative? So if we go, this is pi, where pi over 4 is. We're going to go all the way around. We're going to go around 2 pi this way. So k would be -1 full rotation. So this is going to be pi over 4 plus 2 times pi times -1. Means we're going to rotate -2 pi counterclockwise, so that becomes pi over 4 minus 2 pi. And of course, we're going to have the same denominator, so multiply by 4/4. So pi over 4 minus 8 pi over 4. So that makes it -7 pi over 4. Now, does this make sense to us? Okay, let's see if that makes sense. Because everything that you do should make sense. And we have to make sure that we visualize, we understand what we're doing. Okay? So here it is. And I did this yesterday, and I'm going to do it again today. This is what it looks like, right? So we're going to do pi over 4. So this is going to be 0 radians. So this is pi. So if I'm going to do fourths, it's going to be 1/4 pi over 4. This is going to be 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi, 6 pi over 4, 7 pi over 4, 8 pi over 4. And if I go around more, what would this be? 9 pi over 4. Right? So from here, this is pi over 4, but if I go pi over 4 and a bit more, I'm going to end up with a 9 pi over 4. Does that make sense? And that's what we got. Now what about the other way? The negative angle. So these are fourths, right? So this is pi over 4. This is 0 radians. Now if this is where I am, this is where my angle is, and then I go around once, I'm going to get back to that particular angle again. So this is 0. This is negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, which is negative pi, negative 6 pi over 4, negative 7 pi over 4, and did I do? Oh, 5, yeah, I missed 5, I was like, okay, then that makes it 6 pi over 4, and then this is negative 7 pi over 4. This is where we got. Okay, so this is our answer when we have a positive rotation. This is where the pi over 4 is, and then we rotate k 1 full turn, right? Positive 1 turn. And then this one here, we're going to rotate negative 1 full turn. There we go. Because this is where we are. This is 1 full turn, didn't we? And we're left with negative 7 pi. Okay, I'm only going to do it once. We see it. Okay. Now let's take a look at this. 2 pi over 7. Well, where's 2 pi over 7? This happens to be not a special angle, but that's okay. Doesn't matter. So if this is 0 radians, this is going to be pi. How many parts are we going to cut? It's going to be 7 parts, right? 4, 5, 6, 7, something like that. So 2 pi over 7 would be probably over here. 2 pi over 7. So, one full rotation this way, and one full rotation the other way. So that becomes, so 2 pi over 7 plus 2 pi times 1 full rotation, 1 2 pi. So that becomes 2 pi over 7 plus 2 pi. And what we need to do is we need to multiply by 7 sevenths. Okay, so 2 pi over 7 plus 14 pi over 7. How many is that? 14, 16. 16 pi over 7. Okay, that's the positive side, and then what's the negative? So 2 pi over 7 minus 2 pi times negative 1 becomes 2 pi over 7. Okay, I got positive plus 2 pi times negative 1. Negative 2 pi times 7 sevenths to have the same denominator. So 2 pi over 7 minus 14 sevenths pi. It's going to give us negative 12 pi over 7. Okay, good. Okay, so this one is for letter C. 2. Okay, that means 2 radians. So how can we do this? Two radians, so pi, not pi, 2, so use the pi's. 2 plus 2 pi times 1, that's 1 positive rotation, is equals to 2 times 2 pi times 1, that's just 2 pi, plus 2. Well, we won't have an exact value. This is the exact value, okay? It says round to the nearest tenth. So 2 plus 2 pi is going to give us about 8.28 radians. Can you imagine where 2 radians is? Which quadrant it would be? Okay. Can we imagine that? Let's see if we can picture that. Quadrant 2? How'd you know? You think you can see it in your mind? Yeah? Okay. Good. This is 0 radian. If you go this way, is pi, which is approximately 3.14. Yes? And then this one here, 1.57. Pi divided by 2, 1.57. So 2 radians would be somewhere right there. Yeah. Okay, so this is 2 radians. Yeah, very nice. So that's a positive, and what's a negative? 2 plus 2 pi times negative 1. Negative 1 tells us we're going to rotate negative angle, negative 2 pi. Okay, we can figure that out. So 2 plus 2 times pi times negative 1 equals negative 4.28 radian. Which quadrant is this in? Would be in quadrant 2 again, yeah. But it's going this way.
Oh.
Yeah.
I went the other way around.
Yeah, because it's co-terminal, that means it stops at the same place, but rotating the other way. Good? Yeah. Pretty neat. Okay, let's try this one. This one you're starting at the negative pi over 12. Okay, so from here it's just pretty much easy. I'm going to draw a line here. So it's going to be negative pi over 12 plus 2 pi times 1. So negative pi over 12 plus 2 pi. Okay. We need to have the same denominator. So you're going to multiply by 12 twelfths. And that's going to give us 24 minus 1. So that's going to be 23 pi over 12. And we can just leave it like that. The negative coterminal would be negative pi over 12 plus 2 pi times negative 1. It's going to give us negative pi over 12 minus 2 pi, but I'm going to multiply by 12 twelfths. So it's negative 24 and then minus 1, so negative 25 pi over 12. Okay. Do you want to try the last two? Okay, so give E and F a try. I'll write down the answer. did you get 2.7 and negative 9.9 for E? Okay, we have to make sure that we put the R, okay, because we don't have the pi symbol anymore. So we want to make sure that whoever's reading this knows that it's in radian mode. And then the last one is 13 pi over 6, yes? And negative 11 pi over 6. Good. Awesome. Any questions there? No. Pretty straightforward, something that we've already done before, but the only thing that's different here is in radian measure instead of degrees. Okay? So, now let's take a look at determining angle measures given the trigonometric ratio or given a point. So this one in here, so determine the exact value, okay. Exact values of 5 other trigonometric ratios for theta given the domain. The domain is from negative 2 pi to positive 2 pi. To the nearest tenth of a radian, determine the possible values of theta in the domain of negative 2 pi to 2 pi. Okay, we've done something like this before, just to let you know, remind ourselves, we've done this before, it's just that we've done it in degrees. So how did we do this? This is going to be opposite over the hypotenuse, right? So let's take a look. Opposite, so if you get an angle, oh, here, they gave us between 0 and 2 pi. Okay, I'll deal with that later. So when we look at this one here, actually, let's go back and take a look at what we've done before. Kind of refresh our memory here. Ratios. Able to show it to you because I can't find it at the moment. Let's just do it right now. Doesn't matter. So whatever the angle is, let's think about this. Where is sine positive? Where is the sine positive? First and second. Okay. Quadrant is first and second. Okay, so it's going to be first and second. So that means whatever the angle is, opposite is 2, hypotenuse is 9, right? So figuring out that one, we can think about this. Opposite is 2, hypotenuse is 9, so 2 and 9. Good? Opposite, hypotenuse. Okay, but this is also true over here, 2 for quadrant 2, because the opposite would still be positive 2, radius is still 9. So, what's missing? Determine the exact values of the other 5 trig ratios. Adjacent and the adjacent part, right? The x. Okay, so sine of theta is already 2 over 9. We want to know the cos, tan, secant, cosecant, and cotangent. So to figure that out, the cos, we need the x. How can we figure out the x? Yes, okay. So that would be 9 squared minus 2 squared, right? Hypotenuse squared minus 2 squared. It's going to give you x squared is equals to 81 minus 4. So x equals, x would be 77. So x equals to the root of 77. Okay, so x is root of 77. If x is root of 77, that means cos of theta is equals to root of 77 over 9. Root of 77 over 9. Okay? I'm going to just write down sine theta here so I don't lose that. 2 over 9. What about tan theta? Tan theta is sine theta divided by cos theta. So let's do that. So 2 over 9 divided by cos theta is root of 77 over 9. And I showed you the shortcut for this, right? The 9's cancels, so we're left with 2 over root of 77. Can you figure out the last 3? Secant theta would be the reciprocal of cos, so that would be 9 over root of 77. Cosecant theta is the reciprocal of sine theta, so it's 9 divided by 2. And then the cotangent theta would be the reciprocal of tangent, which is root of 77 over 2. I'm showing you one way. Actually, I did it in a slightly different way before. I'll show you my other way, okay? Is everybody okay with this piece? Yeah, it makes sense, right? Okay, good. I'm going to show you another way. Tell me if this makes sense to you. We got the same answer. We got the same thing, but what did I do? X squared plus y squared equals to 1 squared. So I took the whole thing as the y, and then the denominator is 1 to make it, the radius is 1. Because sine theta equals to 2 over 9, that's the y, I took that as the whole y value. And then the radius is 1. Did we get the same answer? Yeah, we got the same answer, right? So x would be 77, root of 77 over 9. So, just to show you that I've done it differently as well.
So that cos squared plus sine squared equals to
What's that?
cos squared plus sine squared equals to 1.
Cos squared plus sine squared 1. Yes. Yeah, we'll get to that one in our trick. Yeah, because x squared. Yeah, because if, yeah, you're like 2 chapters ahead of me, but yeah, sure. X is cos, right? Y is sine, right? So if we have x squared, that's the same thing as cos squared theta, and then y squared, that's one of the trig identity. That's chapter 3 of our trigonometry. Fantastic, see? I've already done that piece. Okay, so now what's the other angle? So the question is, oh, this is our given angle. Okay, for theta between 0 and 2 pi. Okay, so we're going to do that. So this part is part 1, figuring out the exact values. Now part 2 is figuring out the angle. Well, what's the angle of that? What's theta? Okay, let's go figure that out right now. So sine theta equals to 2 over 9. So theta is equals to, okay, remember our angles are in degree, in radian instead of degree. So sine inverse of 2 divided by 9. Use a bracket. It's going to give us 0.22, it says tenth, so 1 decimal place. 0.2 radian. 0.22 radian. So that means from here to here is 0.2 radian. What's the other one? What's the other angle? So in quadrant 1, theta is equals to 0.2 radians. In quadrant 2, what would it be? It's going to be, from here to here is pi minus 0.2. You okay with that? Pi minus 0.2. Pi minus 0.2, or 2.9. Anyone's going to ask why pi minus 0.2?
Makes sense.
Why does it make sense?
Because it's in quadrant 2, so you have to take it
Yeah,
from the 180.
right. This is our reference angle, right? Reference angle is 0.2, 0.2. So if you want to know what this one is going to be, pi minus 0.2 to get to that one. When we were doing the angles in degrees, it's 180 minus the reference angle, right? Very nice, very nice. Okay, now let's do this piece. Yeah, it says here from 0 to 2 pi, so that's it. Go to this piece.
How do you know that that's it if 2 pi would technically go all the way back around?
Oh, yeah, because that's a good question. So here's 1 and here's 2. This is 1 and this is the 2. So if we go all the way around, that's more than 2 pi. Because the restriction, the theta, is between 0 and 2 pi. We don't have to go all the way around. Let's take a look at this one. Where is tangent negative? 2? 4, yes. So tan negative in quadrant 2 and quadrant 4, yes. So, can we, well, when we talked about tangent, that's opposite over the adjacent. Okay, let's see if we can do that. So quadrant 2 and quadrant 4. So we can go 2 different ways we could do. If we put the negative on the numerator, then that means it's going to be in quadrant 4. Okay, so the y is negative 12, 7. And if we put the negative in the denominator, that means it's negative 7, positive 12. You okay? Make sure that is that okay? I'm not gonna go forward unless it's okay, or somebody answers me, or pretend that you're okay, and you go home. It's like, oh, I actually don't understand this, and it's okay to not be okay. Okay, there we go. Show you if you're just being shy. negative 12 over 7 can be written as negative 12 over positive 7. Yes? So if this is the y and then this is the x, it would look like this. 7, negative 12, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's right here. That's why it's in quadrant 4. Quadrant 4. Now, if we reverse, what if we put the negative in the denominator instead of the numerator? So tan of theta is equals to 12 over negative 7. That means negative on the x, positive y. That's when it's in quadrant 2, right? Like we said, tan is negative in quadrant 2, quadrant 4. Now, everybody understands. And don't be shy. That takes us back to this. Okay, so we have that point, we have that point. We got the opposite here is 12, and then this is negative 7, or this is positive 7, negative 12. Okay, so what we need is we need the reference angle. Reference angle, I'm going to put theta r. Okay, well, what's missing? We got x, y, we need the r, hypotenuse, radius. Okay, so let's, how to figure out the r?
Can we do it by the way you were doing it? The other example now? Remember when you said there was 2 ways?
Oh, x squared plus y squared? Because this one here, this is your y and then this is your x. So yeah, this one wouldn't work out. So we have to go r squared is equals to x squared plus y squared. It's going to be 12 squared plus negative 7 squared. I guess it doesn't matter which one you put it. It's going to be 144 plus 49. $193. So r would be square root of 193. Okay, so let's do the sine, cosine. So sine theta is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Now, from here, sine is positive, cos is positive. Is that true?
Why is it like that?
Is that true? I wrote it down like this, but we had got to ask ourselves, does that make sense? No. Because here, in this particular angle, or this, it's going to be a positive sign, right? Positive y, but over here it's negative. So plus minus. And then here, negative cos here, but positive cos there, so plus minus. So if positive for sine, that would be negative for cos, positive for cos, negative for sine. Okay, next. We already got the tan. Let's go cosecant or secant. What would that be? That's going to be root of 193 divided by plus or minus 12, depending on which one you're looking at. Secant theta is going to be root of 193 plus or minus 7, depending on which one you're looking at. And then cotangent theta would be, it's going to be negative 7 over 12. Okay. Now let's go ahead and figure out theta. So tan theta equals negative 12 over 7. Figure out our theta. Negative 1.0 radian, that's what I got. That one is a reference angle. 1.0 radian. So, what's our theta? Our theta is 1 radian this way, and then 1 radian this way. So our theta here would be, if you go this way, it's going to be pi minus 1. Yes? Right? If you want to know what this part here, you go pi minus the 1, which is 2.1. And then the other one is 2 pi, you can't see that, sorry. 2 pi minus 1. So 6.28, so 2 pi minus 1, 5.28, so that's going to be 5.3 radians. These are the positive, but we want to go to also negative 2 pi. We're just going to use a coterminal for this. These are all of our positive. We're going to do the coterminal to figure out the negative. So if this is my 2.1, to go all the way around, I gotta subtract 2 pi. Somebody looking for me? So the other one is gonna be 2.1 minus 2 pi. It's gonna be negative 4.2. And then the other one, if we have the one in quadrant 4 at 5.3, and if we go all the way around, negative 2 pi, 5.3 minus 2 pi, it's going to be negative 1. So we got 4 different angles in here for that. Okay. Is that good? Okay, we'll see this one. Example 3.
Please excuse the interruption. I just wanted to let those students know that I've signed up for the special language exam. That the exams are next week, and there are still quite a few timetables in Guide Box to be picked up. So if you haven't picked up your timetable yet for the special language exam, please come see Donna in the Guide Box. Thanks.
Okay, do you remember this piece? We got the point. We got to figure out the angle. So this one here is a very specific point. Let's see if we could. So negative 5, positive 2. So if that's the point on our grid, determine the exact values of 3 trigonometric ratios, or 6 trigonometric ratios. Well, what do we have to do first? Find the r, yeah. So this is -5, +2, find the r. So go ahead and find the r, the radius. I'll do the same. Okay, so that was easy, root of 29. Now from here, can we do the ratios? Yeah, go ahead. You can go ahead. I'll do the same. You okay with that one? You agree? I didn't make any mistakes. The second piece, determine to the nearest tenth of a radian the possible.
For like secant and cosecant, secant should be like negative root of 29 over 5. Thought that negative switch places.
This one?
Yeah, for the secant.
Just for the secant?
Yeah, I thought the negative also. It would be negative root 29 over 5. Would it be negative root 29 over 5?
Oh, it doesn't really matter.
Doesn't really
Yeah,
matter.
doesn't really matter. Yeah. Overall would still be negative, right? Yeah. But when we look at this, we said the radius has to be positive. So we're keeping the x as -5. But overall, when you look at it overall, it's still going to be a negative value. Okay, next one. From here to here, what happens? What's that angle? Well, which one are we going to use?
Sine.
Sine? Yeah, we could use sine. Okay. Can we use cos? Can we use tan? We can use any of them, right? But then we have to make sure that we're looking at that angle in standard position, not the reference angle. So, yeah, I can go ahead and pick something and we'll compare our answers. I'm going to use cos. Okay, now it's giving me a negative angle. Where is that in my picture? This is actually a a reference I'm gonna try sine. So this is a reference angle this way. So that's going to be theta is going to be pi minus 0.38. Pi minus 0.38 would be 2.8. 2.8 radians.
Should be 6, right? 30.
30.
Yeah, the hypotenuse.
30. This one? 20 instead of 29.
I think it's going to be on the first.
Okay, which one's 30? It's okay?
I'll do that one.
Oh, you're doing the other one. Okay, don't do the other one yet. Not even there yet. Okay, let's do this one.
I didn't see what you got.
2.8 radians. So it'd be pi, because this is my reference angle, 0.38. I actually went back and did the sign, because it's on a positive. That would be a reference angle. And then I went back, reference angle here is 0.38. Okay, sorry, go back. And erase this piece. So 0.38 is a reference angle, but I need the angle in standard position. Yeah, okay. Can I leave this with you? Yeah, yeah, yeah. Yeah. Because when we take a look at theta r, those are just the reference angle. It doesn't give you the angle all the way to quadrant 2 or quadrant 3. So when they gave us a theta r that's positive, let's say a theta r that's a positive, okay, it thinks that the angle is right there. So theta r is here. Now if our theta r is negative, that actually it's thinking that the calculator, when I say it, it's right here. It's turning this way. So if it's turning this way, negative, it's the same thing as your theta r here, theta r there, theta r there. Okay. So I'll leave the b with you and see if you could figure that out. This one. This piece, I'll scan it, but it's also already in here. Okay. That piece. We're going to move on, because I know some people have to. So we're going to fast forward some stuff. So we're going to page 25. I will scan those on the blog. I'll put it on the blog so you know which ones they are. Okay, let's take a look at example 1. Determine the exact values of 6 trigonometric ratios, okay? Now this one, when they say exact values of 6 trigonometric ratios for each angle, they didn't even tell us what the points are, what the other ratios are. They said it's that. And how can we go about that? The only way they can ask for an exact value is if it's a special angle. And remember those special angles. The special angles are the 45 degrees, 30 degrees, and then 60 degrees. Now, these are all in degrees, special angles in degrees. But what would this be in radian? So this one would be pi over 6. Pi over 6 is 30 degrees.
60 is pi over 3.
And then 60 is pi over 3. And then 45 would be pi over 4. Okay. So when we look at, can we see this in our mind? 2 pi over 3. Where would that be? 2 pi over 3 would be, this is, the pi is cut into 3 equal parts, so that's 1, 2, 3, right? So 2 pi over 3 would be up there. 2 pi over 3. So this is 0, pi over 3. This is going to be 2 pi over 3. And then this is a 3 pi over 3. So what would this be? So 2 pi over 3, cos is -1/2. Sine of 2 pi over 3 is the y value. What would that be? √3 over 2. And then the tan of 2 pi over 3 is equals to sine divided by cos, so it's going to be -√3. Okay, is everyone okay with that? Yeah, okay. Let's back up.
How do you know that cos 2 pi over 3 is negative? How do you know that?
No. Yeah. Maybe I'll go this way. I'll scan this for you.
Oh, right.
Just look at this one, okay?
So it's the same as the other ones?
It's exactly the same thing as the other ones.
Oh, okay.
Yeah.
That's why we just need to.
So when we say pi over 3's, this is pi over 3.
Feel like doing that when it was isolated or like how realize that it's all the same as the other ones.
These are more numbers you have to like memorize basically, or you should memorize them.
Same numbers,
Yeah, it's the same numbers. It's the same numbers, yeah.
just different.
Yeah. Because pi over 3 is 60 degrees. So it would be the same numbers. So 60 degrees, pi over 3 is 1/2. So this is your x and this is your y. Now because it's 2 pi over 3, then it would be over here. So it's -x, positive y.
Okay, that makes sense.
Now that makes sense. Okay, so not too fast anymore.
No.
Okay, anybody else? Okay, please tell me, and I'm not gonna be angry. Like, what do you mean you don't know? What do you mean you don't know? Okay, let's try one more. From here, can we do the other ones? Yeah, that's easy. Secant 2 pi over 3 is negative 2. Cosecant 2 pi over 3 is 2 over root of 3. And then tangent of 2 pi over 3 is negative 1/3. Oh, cotangent, not tan, cotan. Yes? Okay. Now, not gonna move on to the next part unless it's okay. Why is it 1 over this one? Okay, because this one is negative root of 3. You're okay with this piece? Okay, it's going to be negative root 3 over 3. Negative root 3 over 1. So if we take the reciprocal of that, okay, thank you. That's a polite way of saying you forgot the square root. Thank you. Appreciate that.
Oh my god, I missed something huge.
Yeah. So is everybody okay? Now everyone's okay now that I fixed my mistake. Yeah. Okay, let's try this pi halves. Where is pi halves? At 90 degrees. Can you picture it in your brain? Yes. Okay. So what's cos? Cos is 0. Okay, let's picture that. Pi halves is right here. So it's going to be 0, 1. What's sine? Yes, is 1. What's cos? No, not cos. I already did that. Tan. Tan is sine over cos. Undefined. Undefined. Because it can't be 0, right? Secant pi half. Secant would be undefined. Cosecant would be 1, because the reciprocal of 1 is 1. Cotangent is 0. Okay, good. Okay, I think what I'm going to do is I'm going to pause. I'm going to finish up to D. I don't think we'll be able to finish everything. It's way too long, right? I thought I could. I thought we could. Can you picture this in your mind? So it's 3 pi over 4, but it's negative. So that means I'm going to go this way. So pi over 4, 2 pi over 4, 3 pi over 4. You okay? Yeah, that one makes sense. How did I know that it's 3 pi over 4, 3/4 here? So the question is negative 3 pi over 4. So that means if this is 0 and then this is negative pi, I'm going to cut it into 4 equal parts. 4 equal parts, so fourths. So this is 1/4. So from 0, this is 1/4. This is 2/4. This is 3/4. So negative 3/4. I'm not sure if that was your question. It's okay? Okay. Cool. So what's the special coordinates here? Remember, it's like root 2 over 2, root 2 over 2, root 2 over 2, root 2 over 2, which are they both positive, negative, some positive? It's going to the left, so that's negative, and then going down, that means negative. Okay. So cos of negative 3 pi over 4 is negative root 2 over 2. Sine of negative 3 pi over 4 is negative root 2 over 2. Tan of negative 3 pi over 4 is 1. Was that too fast? No? Okay. Just right. Secant negative 3 pi over 4 is 2 over negative root 2, or negative 2 over root 2. Cosecant negative 3 pi over 4 is negative 2 over root of 2, or 2 over negative root of 2. And then cotangent is 1.
I don't know how you do that so fast.
Oh, remember, I've
I guess
done it a long time. You'd be like that too. You'll be like where I am.
Yeah, okay. And I'm dead.
Give it like lots of practice. Do you see where this is? Negative pi over 6. Which quadrant? Quadrant 4? You sure?
What? Guess what?
It's quadrant 4.
Quadrant 4.
Okay. Are you sure?
Negative 5.
Yeah.
Oh, because it's negative 5. So
Negative pi over 6?
Well, you have to separate the 6.
Okay, let's try this. Pi over 6.
Yeah,
So 0, negative pi. So you gotta cut it the negative pi 6 parts. So 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. So where's negative 1? Quadrant 4.
it's right there. Then why do you keep saying that you're sure?
Because she's tricking us.
Yeah, checking it.
Ourselves.
Okay, it is quadrant 4. Because it's negative 1. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Yeah. Okay, so what's the special,
3 over 2.
what's root 3?
Yes.
Root 3 over 2, comma,
Negative 1/2.
negative 1/2. Okay, so let's finish this thing off. Cos,
Looks like it's a beautiful snowstorm with them.
Gotta love spring, right? It's gorgeous.
When? Default.
okay, so I got root 3 over 2, negative 1/2, negative 1 over root of 3. Thank you, I didn't forget the root of 3. Is everybody okay? And then secant cosecant negative 2, and cotangent is negative root of 3. Awesome.
You too good.
Okay. So, I'm gonna stop right here. For you to practice, okay, what if, do you know what the flipped classroom is?
No.
flipped classroom. Nobody have, you know what flipped classroom is? Okay.
Turning
So
something
not very
around.
many people know what flipped classroom is. Flipped classroom is when for you to read ahead, I'll scan everything that I have. Okay. Your homework is to just read up to page 26 of my notes. Okay? You're not doing any work.
Can we copy the notes down?
Yeah, copy the notes down, read the notes. That's your homework. Okay? It's called flipped. And then tomorrow, we're gonna do some work in the classroom, a little bit of work in the classroom, and then we'll do the, if we can squeeze in, we can do the arc length tomorrow. Is that okay? We're gonna give that a try.
Are we gonna be tested on that?
The arc length? Yes.
Where does
No, they're not.
Huh? The test is on for...
Except our click.
Well,
You can't test us. They're not testing. Yeah, I know.
okay, but before you go, I know you're excited already. This is too much for you that we've done so much, and well, you can stay. I know some people are still working. I know some people have. It's not an early dismissal. It's just like some people have appointments. Okay, so certain people need to go. Here's the other thing too. You're gonna be given an assignment. Okay. I'm gonna close this off now. So before you go, I have to give you your hand-in assignment